Hi, welcome to everyone's favourite segment, Mailbag Monday, where I open my mail. And yes, I've said it before and I'll definitely say it again, it's gotten out of control. There's no less than 35 packages here. I think I may have even miscounted. There might be one or two more than that. I can't count that high. Jeez. So thank you everyone who's sent in this stuff, and sorry if I don't get around to opening your stuff. I definitely won't get around to opening most of them on today's mailbag, but let's give it a try, shall we? Got the trusty knife, and well, I don't know. I might start with some swag. Yes, we have some swag, not electronics related as such. It comes from Atlassian, and the software and other geeks, computer geeks, will know who Atlassian is. I won't pretend that I know everything they do. They do collaborative software tools among all sorts of other things. My good mate Rog works there, who you've seen on the blog before. G'day Rog. And they've sent me some swag, and it is, check it out, check it out. Look at that. Angry Nerds. Love it. With the Atlassian symbol on the back. There we go. Awesome. Thanks, guys. I'll link in Atlassian down below if you haven't heard of them. Next up, one completely at random from Germany. Yes, I got a ton of German viewers. Hi to all my German viewers yet again. There's almost, I think, has there been a mailbag without a German, something from Germany? I doubt it. Anyway, this one comes from Christian Finger. I won't make any jokes there. Okay, thank you very much, Christian. And he's from Hude, if I'm pronouncing that correctly, H-U-D-E, in Deutschland. So thank you very much. It's got a description on the outside. I won't tell you what it is. It's not hugely descriptive, but here we go. Oh, it's got little foam. Look at these little foam pellets. Haven't seen any that small in a long time. So let's, hey, yeah, they're going everywhere. They're like they're like beanbag beans from Beanbag. If you've ever accidentally spilt beanbag beans, oh my god, they're horrid. Anyway, Ignore Royal Finger in Stratland Mission. It's a CD. I guess. I have no idea. What? Igor Royal. There you go. I have no idea. I'll have to play that, or I'm assuming, no, it's a DVD. So what I've got to, Fingers Welt. Who are Fingers Welt? They look like happy chappies. There you go. And let's have a look. I've got some green felt stuff. That's just, I think it's just filler. Oh, I do love, oh man, this stuff's getting everywhere. I do love Lego. Awesome, 3-in-1 little tractor Lego. Thank you very much, Christian. That's awesome. Of course, that's for Sagan and Daddy as well. Daddy loves, hang on, I'm gonna do, oh man, there, these, look at them. Look at them. Look at all those, beanbag, little pellet beanbag beans. They clump together due to static. I think it's some static that's causing those to they bounce around. It's quite fun. And having too much fun with the oh yeah, it's going to be a mess. It's going to be a mess. But let's have a look what's in here. What's in here says it's an old measuring instrument. That's all I know. And oh, we love analog meters here on the EEVblog, and check it out, early Philips unit. Look at that, haven't opened a Philips analog meter before. Awesome, thanks Christian. This is a very bland looking meter, analog meter, I must say. It's just sort of like, no edges around here. It's all just sort of, exposed, very sort of basic, sort of low-end type construction, not super rugged. Now, one of the most interesting things about this is, check out this, 1 microamp full scale. How can it possibly do that?
Well, it can't, because it's not a traditional analog multimeter. This is the dead giveaway, electronic. The only way you can get 1 microamp full scale deflection is to have an electronic, or often called a FET VOM, or FET voltometer, FET meter, whatever you want to call it. Yes, it's got a FET amplifier input stage to allow it to measure small currents like that. And it's quite unusual in that there's no terminals on the front. Where are the banana jacks? Well, they're on the side here, look, and just labelled on the top. It's a really quite a piss poor design from that aspect. There's our ohms adjuster on the side. I don't mind that. And we've got ourselves a little positive and negative indicator over here, and just your usual ganged switches here with an off button, because if you leave this thing on, it's a FET VOM and it'll draw power. So there we go. It's got some nice instructions on the back. I like that. And this one's actually made in Holland. So that's kind of like a... No, I don't think they actually use Holland anymore. A lot of people think Holland is what's now known as the Netherlands, but Holland was only a small region of the Netherlands. I'm not sure which part, but a small region of it. But I think people are a bit forgiving if if you refer to like Holland and the Netherlands as Holland. Anyway, here we go. That's a rather neat instructions there, how to battery check, how to do all your adjustments and calibration. Excellent. And there we go, 2 kilovolts input protection, and the frequency range 25 kilohertz. Yes, huge frequency range. Typical accuracy, yeah, 3%, very typical for an analog meter, and 2 9-volt batteries. And that's pretty dodgy. Someone's had a hack at that. Look at the hot snot on the back of that. So they've clearly replaced those with, it looks like, the battery snaps that they got out of the top of the 9-volt batteries. Because if you're ever short of a 9-volt battery, you can actually take apart a 9-volt battery and take the battery snap out of the top there and use it and solder some wires on. And, well, that's what somebody's done here, I think. Which is all fine and dandy, except the bloody things don't fit anymore. Oh! And check out the fuse there. Just screw in a bit of fuse wire. Oh, that's very how you're doing. But it looks like they give you a spare spool in there, so you just unwind it. Oh, goodness. Okay, fair enough. That's neat. And it's got a 1.5 volt battery as well. That would be for your higher current, low ohms ranges. But generally, for just regular measurements, you're almost certainly only going to need the 2 9-volt batteries. And there we go. We can do our battery check, and that's just fine. But one of the most annoying things about these is that, look, you've got to zero the meter out. No, it's not actually faulty, and well, it could be, but in this case you have to actually zero the thing over here, and that's not your regular 0 ohms adjust, which you're used to on an analog meter. That's a separate control over here for your ohms range. This is for your regular measurement ranges. Well, there's no joy measuring resistance at all. It's gonski. And one of the things you'll notice about FET VOMs like this is that the ohms scale is back to front to a real analog multimeter over here, because it's got infinite as full scale there, whereas a real analog meter has 0 at full scale like that. Big difference. But it is bang on for volts. Look at that, 1 volt full scale. No worries. And 2-minute teardown time. Check out that. It's a little bit how you're doing. It's all over the shop. You can see some flux residue left on the components here. Looks soldered on the top side like this. They've sort of like done it as a double-sided board, as in like they've got the pads on the top, but there's no traces on the top that I could see, and they've got wiring running everywhere else. Anyway, there's our ganged switches there, and you can see how they're linked together, and the big bar in there for the off will actually switch those off. So it's got its own board. It's really quite weird. We've got some lashed wiring there, and I've got a bunch of resistors there. That's weird. We've got some like point-to-point wiring down in there. Some more, you know, it's all over the shop. And then we've got ourselves some transistors. They've got little spacers underneath those, and it's really pretty awful. I'm not sure what the hell they were doing there, and sort of like, you know, they got little solder points here. This is for the shield on the back there, but yeah, it's like slapped together. It really is. Not impressed by that at all. Check out those down in there. They look like capacitors. That's got 100 puff on it. Look at that, directly on the input jacks there. Wow. And we can see that again there. Look at the color code. Old school. And there's obviously some current shunt resistors, I would be guessing. And because this is such a high performance instrument, you got to thermally bond the two presumably FETs down in here. Look at that. So that's why they got the metal in there, to keep them at thermal equilibrium, to thermally match them. Yeah, that is just horrid. Look at the flux residue left over on that. Oh my goodness. And this is like a Philips. You know, Philips used to make some really good gear, but apparently not this one.
Next up, one from the old dart. Elliott Veares, from England, of course, for those who don't know what the old dart is. It is labelled open before December. Oops. I'm sorry, Elliott. Let's have a look. Let's have a squeeze. Stop. Read before opening. All right. No worries, Elliott. That's, look at this. Makes a great letter opener. There we go. And let's have a look. It's a Christmas card. Thank you very much. Yes, it is Christmas. It's the 18th today. So, yeah, almost going to call it quits for Christmas, although I work for myself, so, you know, I don't get holidays. And apparently Elliott has come up with a website that allows people to log on and then control Christmas trees. There you go, like, you know, Christmas and decorations and lights and all that sort of stuff using X10 automation modules. So there you go. I'll put in the link down below if you want to play around with Elliott's Christmas lights. Beauty. And apparently this one, he had his hard drive in there, which is metal case, of course, and apparently it arced over to his TV chassis. So that's got to be a isolation failure, primary, secondary isolation failure in this cheap-ass power supply. These things are just bloody horrid. And he's also sending one of these CM11 home automation, you know, wireless receiver thingamabobs. So, hey, 2-minute teardown. So here's Elliott's CM11 automated modules here. They're from a company called letsautomate.com. I assume that they made them. And there's the receiver, of course, so we can switch power, presumably, remotely. And here's our PC interface. Got a couple of AAA batteries down there. That's just the serial USB or USB. I think it's serial adapter, and of course one of those weird ass pommy plugs on it. Got the fuse embedded in there. So let's just crack these open very quickly. Have a look. Wow, I wasn't expecting that. Check it out, old school. It looks like, you know, 1970s, early 80s through-hole stuff, all single-sided board. And, you know, we've got our chokes down in here, and just very, very old school. Unbelievable. We've got one dip package down there. That's got to be our micro or something. Usually a dead giveaway is that they've got a serial number sticker on there, so that's got to be for your serial decoding. But geez, you know, look at that. Unbelievable. I was expecting some sort of surface mount job, not something smack out of the 70s. And I was going to say that's probably a PIC down there, and sure enough, you may not be able to see it. It's very hard to read, very faded, but it's a PIC 16C58. Man, old school. And down in there, we've actually got an Atmel E² prom. Wow. But yeah, I mean, the other chip over there is just a opto coupler for the isolation, but wow. And she's a little bit crusty on the bottom there, and of course, look at this, nice hand taped out, and you can see the isolation around here. Lots of flux residue left over from the hand soldering. Oh, and it looks like we've got just as old school under the receiver here. And look at that, there's the little selection
knobs there, so they just select the various frequencies or whatever, and bingo, we're going to have a matching pick down in there, no doubt, and not a huge amount more. And this thing is weird. It's my first guess would have been it's some relay for the switch in, but yeah, it's very, very bizarre. So yeah, that seems to make sense. We've got, of course, our two larger high current wires here, which looks like goes to, you probably can't see that, but looks like there's a big ass contact down in there. We've got ourselves two coils here, so that's got to be it's almost as if like it's a sort of, you know, they've customized their own relay there, you know, because there's no branding on it or anything. And wow, look at that. How old school is that? Unbelievable. And it just latches from side to side like that. Wow. Look at that. I mean, surely they would have just been able to buy something off the shelf, but maybe they needed the form factor or something perhaps. So yeah, I mean, you can buy these off the shelf, so I don't know why they rolled their own. Anyway, they must have, well, I assume they rolled their own. Maybe this is an off-the-shelf one, or many manufacturers of these things use them. I don't know, but yeah, it's novel. Yeah, so the way these work is that you know, apply a pulse to one side, of course, and you can move the bar across and it just latches in that position, and then you can energize the other one or vice versa, and then you can latch it in the other position like that. So you don't have to keep the coil energized to keep the thing open or closed. And yep, that one's a PIC, but not the same. It's a PIC 16C54 this time. So there you go. That was a interesting little mini teardown. Thanks, Elliott.
Next up, another one from the old data. This one comes from Mark Elliott. By the looks of it, he's scribbled out his name, but yeah, Mark Elliott from Monmouthshire in the UK. Never heard of it. Okay, thanks, Mark. Let's check out what you've sent here. Let's have a squiz, shall we? Okay. Oh, no. People tape their boxes down. No, I'm not going to use anything more elegant. Hey, got some postcards from Tintern. Haven't been to Tintern. Along the river Usk, and some, hey, they got writing on the back. And it turns out that's the Monmouthshire canal. So there you go. Very nice. I like the look of that. He's enclosed a calculator. We love calculators here on the EEVblog. When he started boarding school in 1975. So we have ourselves and something else as a little teardown. Oh, it's a four-banger. It's a four-banger. Commodore. Look at that. Classic Commodore four-banger. Wow.
And I stand corrected, it's not a four-banger. For those who wonder what that term is, it means a four-function calculator. It looked like it by the number of keys, but it has all the scientific functions. So it is a proper scientific calculator. It's got F1 and F2. So you press F1 and you can get sine, and F2 and you can get, you know, inverse sine, and R to P, P to R conversion. Awesome. And yeah, it's a bit inconvenient because, like, to get your exponent is just, you know, really hopeless, but still it can do it. 1975 vintage Commodore. It's going to have, looks like a red LED display and serial number 8066. Not sure what the model number is. Here we go. I'm going to power it up, and yes, it's got one of those red bubble displays in it, and yeah, was this like Commodore's first ever calculator? It may very well have been. So, ta-da! Oh, no, kind of sort of works. Oh, there we go. There we go. And, well, not many digits on it. It's probably going to leave a couple in there for the exponent. So if we have to go to the exponent there, yeah, there we go. We can, yep, -3, ta-da! And then we can maybe get the log of that. Ta-da! Oh, it takes a bit, but it got there. And as with all these calculators back in the day, yeah, there's nothing to them. Use one of these National Semiconductor, I believe, LED bubble displays. There it is. I've still got a whole bunch of those. Look at that. We got ourselves a Commodore. It's a 3 chipset solution there. Wow, that's advanced. Usually they're only a single chipset solution. And, well, bugger all. So that's, I presume, that's the display driver. And this is the calculator engine. Not sure what that puppy there would be. But we're talking 1976. There we go. 23rd week, 76. They're all, yep. So, wow. Yeah, that's just a Commodore custom ASIC, I guess. There's nothing else in it. A couple of jumpers. Geez, they couldn't get the single-sided layout, fail on the single-sided layout. The holy grail, of course, of single-sided layouts is to have 0 jumpers. They couldn't get it. And Mark also sent in one of these universal VGA to HDMI converters, i.e., you know, standard VGA input, and there's the audio as well, and you get your HDMI output, of course. So yeah, it supports reasonable resolutions there. What is the interesting part about this is that I used to work on this stuff back in 1994 at KeyCorp, and back then it was rocket science to do this. We had a board 10 times bigger than this just to do like 640 by 480 VGA to LCD conversion. Like HDMI wasn't around then. It was just like whatever custom you know, interface your VGA had. And now, ta-da! Look, there's bugger all in it. A couple of, basically 2 major chips, and that's it. There were no chipsets when I was a boy. And, you know, you had to implement the thing all yourself, or most of a good lot of it yourself. And we had a ton of logic to actually do it. Lots of programmable logic and other stuff. But now it's just, yeah, somebody's done it all, whacked it in an ASIC. Too easy. But now anyone can buy these chips from DigiKey or wherever, lay out a board in a day, and Bob's your uncle. So yes, we take it for granted these days you can just do this sort of thing, but 20 years ago, let me tell you, you know, taking the VGA input, as I said, only 640 by 480, and actually recovering the clock on that, and you know, doing the analog to digital conversion, and all the you know, the reprocessing of that and outputting it. Geez, it took a lot of effort, and if you didn't get it right, you'd get, you know, jitter on your dot, you know, on your individual pixels, and it was you know, horrid. I mean, we were pushing it to 800 by 600, I think, by the time I left there, and yeah, like it was, you know, you had to hold your tongue at the right angle to get the clock right. Man.
Open soon. Somewhat time sensitive. Not sure I've had this one laying around, but anyway, sorry to Peter Murray if I haven't opened it on time. Somewhat time sensitive. He's from Niagara Falls on the Canadian side, not Canberra. So don't mix up Canberra, where our bloody dickhead politicians are, with otherwise it's a nice city. Yeah, visit Canberra. I like Canberra. So hi to all my Canberran viewers and all my Canadian viewers as well. So let's see what Peter's sent. We have ourselves, looks like, a kit. Let's go.
And what do you know? Pete's actually a bloody POM. There you go. I mean that affectionately, of course. He's designed an old PickKit 2 clone while he's in college, and he's also done a power supply. And he's got an Indiegogo campaign as well. So we'll check that out. Hopefully we haven't missed it to get him back to college. So here's his boards, and we've got a couple of crusty old parts as well. And first up, here's a ceramic hybrid module which Pete's made while he was back in college, and very traditional hybrid arrangement. If you haven't seen these before on the ceramic back, I mean, there's nothing, you know, hugely special that requires the ceramic substrate on here. You could have done that on a FR4, of course, and just a regular fiberglass board. But usually with hybrid boards like this, you don't use like the regular you know, 0805 or 0603 components which Pete's used here. Usually you'll have those and embedded as part of the substrate, hence the name hybrid. So there's essentially nothing hybrid about this from that aspect that I can see anyway. I think it's all just regular surface mount components, but on a hybrid like ceramic backing in there. So this is a just a regular function generator. And there's his PicKit 2 clone. A lot of people did a PicKit 2 clone back in the days. It was quite common, but geez, Pic haven't updated their PicKit in a long time, have they? How many years has it been now? Jeez. And he's also done a digital programmable power supply with dual 12-bit DAC, I think he's got here. And what is it? Yep, a 13-bit 8-channel ADC as well for measuring the voltage and current and the pots and all that sort of stuff. FTDI isolated interface and CAN bus comms as well, so you can daisy chain the boards together. And this my power supply was the inspiration. My micro supply, which I'll eventually get back to, was the inspiration for this. So that's awesome, good to see. And I'll link these in on Peter's website down below if you want to check it out. And he does have 23 days left on his Indiegogo campaign to raise funds to get him back to college. So if you can help out Pete, please do. There's the link there, but I also include it down below as well. And he's also got an unpronounceable YouTube channel there, which I'll link in down below as well. He's got some teardown videos, so check him out. Thanks, Pete. And we've got some old school parts as well, and these are germanium transistors, and yes, as he says, they are light sensitive, so you can actually cut the can off the things and use them as well, rather crude light sensors. So yeah, very common. There's some useful applications for that, and some people do use those in practical circuits. But Mullard, look at that, made in Great Britain. Terrific. Well, here's a POM.
Next up, we have a commercial one. How can I tell? Well, it's FedEx. Regular humans don't generally pay for FedEx. It's too expensive. Companies do because they got their FedEx account or whatever. So I have some clue what's inside this. So let's check it out. It's from Antron Services. I'm not sure if that's the shipping company or that's the company who make it. I can't recall. I was clued up on this one. It's been around for a while, so my apologies. Let's have a squeeze. Oh, it's from the local, from the suppliers, or might be the manufacturers. Tekbox. What is it? It's an EMC probe set. Awesome, and so it is. So Tekbox, so that Antron Services, that was probably the shipping company or something. And, whoa, look at that. Isn't that sexy? There we go. Made in Vietnam. Well, maybe the box is. No, it's also got made in Vietnam on there as well. So is the probe actually made in Vietnam? And I have a postcard. Greeting Dave from HCMC. More pre-compliance accessories to come soon. Hein. Thank you very much, Hein. And let's take a look. I won't open it here. Let's go open it on the other bench.
All right, what we have here is the TBPS1WA blah, 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 made in Vietnam, but lovely little box it comes in. EMC probe set. These are going to be near-field probes. Let's have a look. Woohoo! Look at that. Doesn't that look beautiful? Well, we've got ourselves various size near-field probes. They'd be the H field, they'd be the magnetic ones, and it's probably, I assume, that we'd have an E field one as well, or they might all be H field. Have to have a look. Anyway, we've got ourselves a little wideband amp. There it is, 3 meg to 3 gig. Nice, that'd be fairly linear. So basically, well, I'll explain and maybe demo this in a minute, but it looks like we've got an SMB connector on the end here, and we whack that over to the RF input, and then we hook the RF output, of course, up to our spectrum analyzer, and we can get do EMC pre-compliance with this sucker. There we go. We've got ourselves an adapter cable for our spectrum analyzer and a USB cable to power it. And let's have a look. We've also got a manual here. Near field probes. Yeah, H and E field. Okay, so yes, the smaller one must be the E field probe. because there's two types of measurements you can do with these things. H field, which is your magnetic field measurements, and E field, E for electric, of course. So you can do your electric field measurements, and they're basically two separate tests. And the reason you're going to get different size, I assume that these are all your H field ones. The reason you get different size ones is that you get better coupling with the big ones, but with the smaller loop, that'd be, so we'd have our loop around there. This one's smaller and this one's smaller again. For the magnetic H field, you can pinpoint more easily exactly where your issue is with the smaller ones. So that's why you get a couple of those, whereas you don't need that with the E field. Just the one will do the trick. So these are designed for EMC pre-compliance. So basically testing your own product in-house before you go and spend your thousands or tens of thousands of dollars to get it actually qualified at a proper EMC test lab. And the interesting thing about these is that not only can you use them to pick up magnetic fields in EMC, you can use them to generate as well. So you can, feed the signal. You can actually feed a signal and like sweep a frequency into here, and you can generate stuff. So if you got yourself a PCB, it's just a random PCB lying around, then you can actually generate a field in here and actually try and couple that into your product so you can test for electromagnetic conformity in that way, that external magnetic fields at a certain frequency, or as I said, you can sweep it over a frequency, don't interfere with your product under test. So they can be used for sensing fields as well as generating them as well if you want to use them in the reverse direction. And these go for under $400. You can actually buy them on Amazon. I just had a quick squiz. I'm not sure what the price is anywhere else, but certainly people are selling them on Amazon, and you get a CAL certificate with it as well. And these are our 4 probes. Yeah, we've got our 3 H field probes. So I assume H20 is like the 20 millimeter diameter, 10 and 5. I'm assuming that's what those mean. So the 3 H field probes over the full 3 gig frequency range, or 300K, actually 300K to 3 gig, and our E field one as well. But if we have a look at the manual, we can probably find that the E field is different. Yes, first page, here we go. This is what I'm talking about. So what your magnetic or H field probes are going to give, they're going to give an output power in dBm versus frequency. So this is the response for the different size ones. So there's a 20 millimeter one like that, which drops off at about a gig there or thereabouts, and the various sizes, and then for a given field of 1 micro Tesla. So if a known input field, a known input magnetic field in Teslas will give out a certain output power dBm versus frequency, whereas your E field probe, your electric field probe, is basically entirely different because it's an electric field which is volts specified in volts per meter. So once again, you'll have an output power here versus frequency for a known field, a fixed known input field of 1 volt per meter. But not only are they useful for like just bare PCBs like that to check traces and and components and all sorts of aspects to your PCB design, they can be used on final enclosures like this. So you can actually go around and find that, okay, we got some leakage around these RCA ports here, or around our HDMI, for example. So, but it's an art in its own right, actually doing a proper EMC pre-compliance measurements. And I could do, there'd have to be hours and hours of instructional videos to actually, to go through all the ins and outs of that. But yeah, these things are really very nice. If you're developing products, it's a really cheap way to, make sure you're at least in the ballpark before you go to your EMC test house, and you can spend, like time and money. Of course, time is money, so even more money by going there. So you can make sure your design is, have a good chance of success. But of course, you've got to understand the various standards and specifications and how to do the measurements and all that sort of stuff. So maybe all that stuff is on the Tekbox website. So with a cheap spectrum analyzer like this Rigol DSA815 and a near-field probe kit and the listen devices I've done a separate video on, also from Tekbox as well, which I'll link in down below for EMC pre-compliance. I already have one video on that, but these are your, for under $400 to get one of these near-field probe sets, you can do complete EMC pre-compliance for like well under $2,000, and that is like, trust me, that's unheard of. I mean, it cost an absolute fortune just 5 or 10 years ago. You had to have a real high-end spectrum analyzer, but now they're really cheap, and these have got, you can buy the EMC pre-compliance plugin for this as well, which helps you more easily meet the standards and stuff like that. But anyway, this won't be a proper video on EMC pre-compliance, just playing around here to see what we do. And I've got my E-field probe in here, and we can probe around and actually have a look at not a circuit, but just the interconnecting cables and the spectrum analyzer itself. Watch what happens if we put this over our cable here. Look at that. We're picking up something at 900 megahertz there, and you see it has to get very close. This is on the shield of the cable here. This is why it's called a near field probe, because it has to be near to the product, so or near to the item that you're trying to test. And right at the BNC USB down in there, and at that headphone output jack. Whoa, look, if I stick it in that headphone jack, it's really going off the scale, and nothing's sort of escaping from our end connectors here or anything like that. It's just fine. But our around the USB and everything here, well, there's something huge happening at 900 megahertz. And then we can have a play around with this HDMI board we were looking at before, and we can probe over that. I've got like the full span here, and we're probably not going to see a huge amount. Get over the crystal there. Yeah, there's something happening down at the low end, as you'd expect. So this is over the full 1.5 gig. So let's go down to the low end and see what's happening down there. If we probe our crystal again, bingo, look, we've got a peak there at 36.85 megahertz. And that's not surprising, because this is a 12.28 megahertz. So one third of that frequency. So we must be getting a harmonic there. So expand that out. And here we go. We got our fundamental here around our clock there, our crystal, and that's at 12.2. Well, it's marked 12.28. We're getting 12.23 megahertz there, near enough. And then we've got one of our harmonics here at 36, at a multiple of that, of course, 3 times that, at 36.96 megahertz. So you can actually probe around not only parts, but you can follow traces and things like that and find any signals on your board. Really quite neat, and it just lets you do. And if you know what the standard is, and you know that, it's not, I screwed up the layout on this and it wasn't supposed to emit there, and all that sort of jazz, then yeah, you can find this stuff really easily with these sorts of near field probes. Now, the way you typically use these is that your E-field probes are basically for very close direct contact here, which is why we're seeing nothing until we go like directly over the crystal there. So you can track down like maybe individual pins or individual traces on large scale stuff. It's harder on, really fine surface mount stuff like this to try and pick it up. Whereas your magnetic field, your H-field probes are designed to pick up your larger loop areas, like your ground loop areas, which is one of the big things for EMC compliance, is that you have to keep the golden rule of PCB layouts: keep your ground loop or your loop areas small. So that means going from your power supply all the way out. The loop area includes your ground on here, includes your ground system plus the power wires to get there, and any signal stuff. So it's an entire, where the current flows in the entire loop, and that's where these H-field or magnetic field probes pick up. So we're picking up a lot more crap, as you can see, going around here with our H-field probe. We're not just picking up that individual crystal, so we're picking up all sorts of crud on here due to, you know, other clocks or other signals that are all looping around this board right back to the power supply. So that's the difference between the H field probes and the E field electric probes. And one of the things you can do too is you can use the demodulation functions on these. A lot of the old greybeards do this. They will plug in some headphones here. That's why it's got a headphone port, so you can demodulate the signals and you can actually listen to it. And you know, all your greybeards will go around, you know, scanning the board, listening in their headphones, stroking their beard with their other hand, with their third hand, and going, "Yeah, there's your problem." And if you're still a bit confused over the H field versus E field thing, well, just remember what EMI is, what it stands for, electromagnetic interference, and or EMC, electromagnetic conformity. Electromagnetic, there's electric fields and there's magnetic fields, and depending on whether you're near field, far field, whatever, or high voltage, low current, or high current, low voltage, that kind of stuff, that depends on which field is going to dominate and which you can actually measure. So generally speaking, at high voltage, low current stuff, the E field is going to dominate, so you're going to want to use an E field probe, for example. But for high current stuff, then, which is going to be, as I said, like, you know, loop area, big loop area on a PCB, and, you know, there's a chip just drawing, you know, huge gulps of current or something like that, generating big magnetic fields, then generally at a specific distance, the H field, the magnetic field, is going to dominate. So you're going to want to use a magnetic field. So there you go, just keep that in mind. EMI, electromagnetic. So thank you very much, Tekbox. This is an awesome set. It's going to come in real handy in the lab. Oh, there it is down there. It's empty. But yeah, well worth the dollars if you're doing EMC pre-compliance. As I said, under $2,000 for something like this. You can do it really well. I mean, it might seem like, you know, a lot of money, but it saves you a ton of money, one of these things, and pretty essential if you're doing product development. And it's also essential to get the calibration certificate with it as well, so you know the exact performance of this. So because you're actually doing quantitative measurements here, trying to at least see if you're going to get in the ballpark of passing your standards. So you know you're also paying for the calibration and certification of these things. So very handy. I'll link in these down below at Tekbox if you want to check them out. So I hope you enjoyed that mailbag. I didn't open as many as I thought I would, and I've got a massive backlog. And not only the ones I got through today, I got even more today turned up. If you're following my Twitter feed, you would have seen the photo. And this huge looking Tektronix box has come. No, it's not from Tektronix. It's from a viewer. So I might do that one as its own mailbag, because I know what's inside. Anyway, I'll leave you guessing. Catch you next time.